Hello everyone. Today we are going to start the vectors. It's one of the most important part of physics. Many physical quantities in physics are the vector quantities. So in order to understand them very well, you should be extremely good in this topic, the vectors. So as usual, you can take out your notebook and pen, and wherever you require, you can pause the video and you can make your notes. In between the video, you'll get few checkpoints. You can pause at those locations and then try the questions for better conceptual understanding. Answers of all these questions can be verified at the end of this video. So let's begin with the index of this video. First of all, we will be going through the physical quantities, namely scalar and vector physical quantities. Then we will see the representation of the vectors. After that, we will see the type of the vectors, and then we will see the multiplication of a vector with a scalar. And at last, we will be going through few important rules regarding the vectors. Okay, so let's initiate. Our first topic is the physical quantities. What is the meaning of physical quantity? Post your opinion in the comment box. The answer is pretty simple. Any quantity which can be measured is known as the physical quantity. For example, length, mass, velocity, time, acceleration, pressure, electric current. There could be numerous examples in physics. In physics, we won't be studying the quantities which can never be measured. For example, suppose you get extremely good result and you become very happy. Can you measure that happiness over some scale? I am 2 kg happy today, I am 10 meter happy today. Is it feasible? No. It means your happiness cannot be studied under the physics. Similarly, let's say you score lower than the expectation of your parents. Then your father changes the geography of your face. Now you are in deep trouble, sorrow, grief. To your friend, can you explain your pain? Today I am feeling 10 kg sad. Today I am feeling 1 kilometer sad. That is also not possible. So we will not be studying such thing under the physics. Okay. The physical quantities are divided in two parts, namely the scalar quantities and the vector quantities. First, we will see the details of the scalar quantities and then we'll go through the vector quantities. Scalar quantities are those quantities which have magnitude with proper unit and they do not need any direction. For example, length, mass, time, speed. Let's take few examples. Suppose you tell the length of marker to be the 7 centimeter. Now this measurement doesn't require any direction. Right now, the temperature of this room is 30 degrees Celsius. That measurement also doesn't need any direction. So the length of the marker is a scalar quantity. The temperature of this room is a scalar quantity. Let's say some car is moving at a speed of 40 km per hour. Then that 40 km per hour doesn't require any direction. So the speed is also a scalar quantity. Getting my point? Okay. Now let's talk about the vector quantities. Vector quantities are those quantities which have the magnitude with proper unit, which have the direction and strictly follows the triangle law of vector addition. For example, velocity, acceleration, force, small angular displacement, so on. We have numerous examples in physics which are the vector quantities. This triangle law of vector addition you will read in the next video. Okay. One thing you should keep in mind in physics, whenever we are talking of a physical quantity, we always put the magnitude with proper unit, such as if you report the temperature, then you report 30 degrees Celsius. That degree Celsius is a unit. You report the length of the marker, you report 7 centimeter. So centimeter is a proper unit associated with the magnitude. Okay. Now, the vector quantities have a sense of direction. So their addition, their subtraction, their multiplication will be done using some special rules. While as the addition, subtraction, division, multiplication of scalar quantities can be simply done using the rules of algebra. For example, if I talk about the scalar quantities, suppose the mass of this pen is 50 gram and I put the another pen of 50 gram. How much is the total mass? What is your answer? 100 gram. Getting it? No sense of direction required. Simple algebra. I put the third pen. Now what is the total mass? 150 gram. Now if I remove any one pen, then what is the remaining mass here? 100 gram. So using simple algebra, you can solve the scalar quantities. But vectors are different. Take an example. On this pen, you apply a force of 2 Newton from this direction and you apply another force of 2 Newton from this direction. How much is the net force on the pen? 2 Newton from this direction, 2 Newton from this direction. Correct. The force is 0 Newton. Net force is 0. Now on the same pen, if you apply a 2 Newton force here and another 2 Newton force here, now both the forces are in the same direction. How much is the net force on the marker? Now this is 4 Newton. Interesting. In the previous case, the 2 Newton and 2 Newton force resulted into 0 Newton. And in the new case, the 2 Newton and 2 Newton are resulting in 4 Newton. So the addition of the vectors, the addition of the forces require special set of rules. The 2 Newton and 2 Newton could give 0 resultant as well as the 4 Newton, and in between 0 and 4 you can get various other possible resultant. Okay, we'll read the details in the upcoming videos. You can note it down up to here and then we'll go further. If you have any doubt or any query, you can fire up the chat box. Why the vector needs a sense of direction? I'll explain it with a real life example. The Karni Mata temple is a very famous temple situated in Bikaner. You can Google about it. Suppose some foreign traveler asks me, where is Karni Mata temple? And then I tell her that the temple is 25 kilometers away from here. Can she reach to the temple? It's tough because 25 kilometers from here can be in this direction, can be in this direction, can be in this direction, can be in this direction. From here, there are infinite directions in which a person can travel 25 kilometers. Then how that traveler should go? Should choose which direction? But if I tell her that from this point, if you travel straight across the national highway in the north direction and you cover up 25 kilometers, you will reach to the Karni Mata temple. It will be easy for her to locate the temple. So that's why we need a sense of direction. Okay, let's go further. Our next topic is the representation of the vectors. In physics, the vectors are represented using the arrow. This length of arrow tells you the magnitude of the vector and this gives you the direction of the vector. The direction of any vector is always from tail to head. This is the tail of the vector and this is the head of the vector. So sense of direction you should keep in mind is always from tail to head. Okay. In books, if we want to indicate the vectors, that is done using the arrow over the symbol. Force is a vector physical quantity, so you will put the arrow. Otherwise, you can write it bold. Some books or some people use such notation also. If a letter is written in bold, you should think about the vector physical quantity. In this video or upcoming videos, I'll be primarily using this kind of representation for the vectors. Getting it? Now, the magnitude of a vector, if someone asks you, because every vector will have some magnitude, that will be represented by mod. Let's say you want to represent the magnitude of the force, then you will write it as modulus of the force vector, or it can be simply written as the F. Getting it? Whenever you show such kind of representation, it means you are talking about the magnitude of that particular physical quantity. Okay, I'll take few more examples. Suppose we have a force of 5 Newton acting on a block. This block is resting here on the ground. I am calling this force as F1. Okay, this is x-axis and this is y-axis. I ask you to represent the force F1 in the vector form. Then how you will write? Give it a try yourself. I am writing it on the board. The F1 vector will be written as 5 Newton magnitude with the proper unit along positive x-axis. This is how you will represent the vector. Okay. If someone asks you the meaning of mod F1, then what you should reply? Mod F1 means the magnitude of vector F1, and the magnitude of vector F1 is only 5 Newton. Clear? Some books will represent this as simple F1. Okay. Taking up another example, suppose we have another force F2 here, and that F2 force is having the magnitude 2 Newton. How we will represent this? The F2 vector will be equal to 2 Newton along the positive y-axis. Because a vector should have the magnitude as well as the proper direction. So here is the magnitude and here is the sense of direction. If someone asks you about the magnitude of the force F2, then your answer should be 2 Newton. And this is represented as mod F2 vector or simply F2. Clear? Another important thing, suppose here is some force F3 in this direction. Then how you will represent the symbol of F3? Shall you write F3 like as this, or you should write F3 like as this? What is your opinion? The first one or the second one? Post your answer in comment box. Actually, the correct representation is this one. This is wrong. Wherever might be the vector directed, in this direction, in upward direction, in this direction, any direction, always whenever you are representing the symbol of vector, the arrow will be like this only. It's a standard notation. We cannot alter that. Fine? Okay. Now, let me ask you few questions for the conceptual clarity. Suppose if I ask you F1 vector is greater than F2 vector, true or false? Think about it and then post your answer in comment box. I am writing few more questions. F2 vector is greater than F1 vector. Mod of F2 vector is less than mod of F1 vector. Do your calculations, think about them and then post your answers in comment box. Here are 3 questions for conceptual understanding. Okay, let's check your answers. F1 vector is greater than F2 vector. This is actually a wrong statement, a false statement. Why? One force is in the x direction, other force is in the y direction. You cannot compare them. If two forces are having different directions, you cannot compare them. Let's say some velocity is along north direction and some other velocity is along east direction. You cannot compare them. You can compare the two velocities which are along the same direction. Getting my point? If both the forces were along the same direction, then you could compare the vectors. But here these two forces are along different directions, so you cannot compare them. This is a wrong statement. By the same logic, this is also a wrong statement. Okay. Third statement, mod f2 is less than mod f1. See, mod f2 we already know is 2 Newton and mod f1 is 5 Newton. It means this is a correct statement. Clear? I am taking one more example to illustrate few things. Suppose we have a car and that car is having the speed of 5 meter per second along the x-axis. Now, if I write the fourth question for you, that f1 vector is equal to v vector, what is your opinion? F1 vector we have already defined and v vector also you can define. The v vector will be 5 meter per second along the positive x-axis. Is this a true statement or false statement? Correct or wrong? Think about it. This statement is actually wrong. Force is a different physical quantity and velocity is a different physical quantity. You can never compare them. You can compare two forces, you can compare two velocities, but you can never compare a force and a velocity. So this is wrong. I am writing the fifth question for you. Suppose I write mod f1 is equal to mod v. Pause the video here, think about it and try to post your opinion in comment box. This is actually wrong. Why? Mod f1 means the magnitude of the force, and in physics the magnitudes are always written with the proper unit. So this is actually 5 Newton and this thing is actually 5 meter per second, and you cannot compare 5 Newton and 5 meter per second. Getting my point? I hope you have represented that velocity in correct manner. How you have written that velocity? That velocity is 5 meter per second along positive x-axis. So the magnitude was 5 meter per second and you cannot compare it with the magnitude of the force 5 Newton. Okay. You should write all these informations about the vectors and then we'll go further. Our next topic is the type of vectors. First of all, we'll talk about the parallel vectors. By definition, parallel vectors are those vectors which have the angle in between them as 0 degree, means they are along the same direction. Okay, you can see the representation here. Next is the anti-parallel vectors. As the name indicates, if the angle between two vectors is 180 degree, then they will be known as the anti-parallel vectors. The next topic is the equal vector. Equal vectors are those vectors which have the same direction, same magnitude and represent the same physical quantity. It means the angle between these vectors will be 0 degree. Okay. Next variant is the opposite vectors. Opposite vectors are those vectors which have the same magnitude but opposite direction and represent the same physical quantity. Fine. Theta will be 180 degree for the opposite vectors. Next is the concurrent vectors. You can see the diagram here. Next one is the coterminous vectors. As the name indicates, these are the vectors which are terminating or meeting at the same point. Next is the coplanar vectors. Coplanar vectors are those vectors which are lying in the same plane. You can see the illustration here. I'll give you the example. Suppose this is a vector and this is another vector and they are kept like this. Now you can consider them to be lying in this plane. So they are coplanar. Now if you put them like this, you can consider them to be lying in this plane. So again they are coplanar. However you put the two free vectors, you can always find a plane in which these two free vectors are contained. Suppose you put them like this, then they are lying again in the same horizontal plane. You put them like this, they are lying in this plane. Okay. So two free vectors are always coplanar. Getting it? Next variant of the vector is the co-initial vectors. Co-initial vectors are those vectors which are starting from the same point. Next is the polar vectors. Polar vectors are those vectors which have a fixed starting point or the point of application. For example, if a force 5 Newton is applied on a box, then there is a point of application of that force. So this force will be counted as a polar vector. Another example, from your home you go to your school, then there is a displacement vector directed from your home to the school. There is a fixed starting position and there is a fixed ending position. Such kind of vector is also known as a polar vector. So displacement is the example of a polar vector. Clear? There is one thing important about the polar vectors. The polar vectors cannot be displaced. Why? Suppose your displacement vector is from your home to school, and now if you displace that vector somewhere else, then the starting point will get changed as well as the ending point will also get changed. Then entire quantity will get changed. Getting my point? Suppose you apply 2 Newton force here. Okay, force is a polar vector, we know. The force will create some effect here. But if you displace this 2 Newton parallel by your will, then this 2 Newton, will it create the same effect or it will create the different effect on the marker? Think about it. If you displace that 2 Newton here, the marker will rotate easily. The effect of the force got changed. So if a 2 Newton force is acting here in this diagram, you cannot displace it parallel. You cannot displace it anywhere. It might change the effect of that quantity. Okay. So keep in mind, polar vectors cannot get displaced. Next is the axial vector. Axial vectors are related with the rotational effects. Suppose we want to represent the angular velocity, angular acceleration, small angular displacement, then we will be using the axial vectors. They are named as the pseudo vectors also because they do not have any starting point. For example, suppose you look at the bicycle wheel. This bicycle wheel has the angular velocity. To obtain the direction of this angular velocity, you curl your right hand fingers along the direction of the motion of the wheel. Then your thumb will point along the direction of angular velocity. Okay, I'm taking another example. The earth is spinning from west to east. Then along the spinning direction of earth, you curl your right hand fingers. Then your thumb will point upward. So the angular velocity vector for the earth is upward as shown here. Now this upward vector has any origin, any starting point? Along the entire axis, the vector is upward only. You cannot find any starting point for such vectors. That's why they are known as the pseudo vectors. Taking up another example, suppose you switch on the fan in your room and looking at the motion of blades, can you find their angular velocity vector's direction? Omega vector. Post your answer in comment box. You can write up to here and then you'll get a checkpoint. The next topic is the unit vector. So unit vectors are those vectors having magnitude 1 and pointing in a specific direction. There is no unit of the unit vector. They are always unitless and dimensionless. You can see a diagram here. Along the x-axis, we have taken the unit vector to be I cap. Along the y-axis, the unit vector is j cap, and along the z-axis, the unit vector is k cap. And what is the advantage of this thing? Suppose we have a car. That car is going with a speed of 5 meters per second along the positive x-axis. Now you want to represent the velocity of this car. Then what you will write? 5 meters per second along the positive x-axis. And the same thing can be written very beautifully as 5 meters per second of I cap. See which representation is better, which representation is more convenient for us. This one. So instead of writing along plus x-axis, we can use this notation I cap. I cap represents simply the positive x direction, nothing else. The magnitude of this vector is 1. So 1 into 5 will not hamper your original data. I'm taking another example. Let's say the wind is blowing along the y-axis and wind is blowing at a rate of 2 meter per second. Then how you will represent the velocity of the wind? The velocity of the wind can be written as 2 meter per second along plus y-axis. Vector should have a magnitude with proper unit and a direction. So all components are here. But same thing can be represented very beautifully as 2 meter per second of j cap. J cap is just indicating the positive y direction. That's it. Okay. Mod I cap, mod j cap and mod k cap means magnitude of these unit vectors will always be 1. Got my point? Here you can see a formula for finding the unit vector. The unit vector is always equal to the vector divided by its magnitude. And the unit vectors are indicated by the cap notation. Wherever you see such kind of cap, you should think about the unit vector, such as if you write a cap, it means it should be a vector divided by the magnitude of a vector. Getting my point? This is unit vector, this is the vector itself, and here is the magnitude of vector. Note it down, then we'll go further. Now you can see the representation of the standard directions using the unit vectors. Along the north we will have the unit vector j cap. Along the south we will have the unit vector minus j cap. Along the east we will have the unit vector I cap, and along the west we will have the unit vector minus I cap. So if you take these directions in the plane of the board, then up and down directions will be perpendicular to the board, means up will be indicated here as k cap and the down direction will be indicated inside to the board as minus k cap. You can see it through the diagrams. Let's say you take up, down and east, west in the plane of the board, then north and south will be perpendicular to the plane of board. Any four directions if you consider in a plane, then two directions will be perpendicular to that plane. Getting my point? Okay. Another important thing, the earth attracts everything towards its center. So that direction is always taken as the downward direction, and perpendicular to the downward direction we will have the horizontal plane. Sometimes you will get the language in the question, there is a horizontal plane. It should give you the idea that it is perpendicular to the direction of the gravity. Getting my point? We will not be using the word ground usually because the ground can be rough, there could be up and down, but horizontal plane means it will be having the same level. So doing the calculations for the questions will become easy. Okay, note down all these things, then we'll go further. I'm taking an example to illustrate the sense of directions clearly, how to write them. Suppose this is north, this is south, here is west, and this is east. Okay, along the north we will always consider j cap, along the south we will consider minus j cap, along the west we will consider minus I cap, and along the east we will consider plus I cap. Suppose there is some direction like this and angle here is 45 degree and you want to write about this direction. Then how to write it? you can write it as 45 degree north of east. I'll explain it once you pay the attention. 45 degree you have traveled towards the north. From which direction? From east direction. Or the same sense of direction can be represented like this. You can travel here 45 degree. So what you will write? 45 degree traveling in which direction? East. Of which direction? North. I hope you get my point. And this direction simply can be written as northeast. Okay. Taking up another example. Suppose here is some direction indicated and this angle is, let's say, 15 degree. Now you post your opinion in comment box how you will indicate this direction. This will be indicated as 15 degree south of east. I hope you get my point. You have to travel 15 degree along the south direction from the east direction. Okay. The same representation can be done in another way. This angle will be how much? 75 degree. So you can write it as 75 degree east of south. Clear? Can you call this direction as southeast? The answer is no. Southeast will be exactly at 45 degree. Northeast will be exactly at 45 degree from the east axis or the north axis. Getting it? Taking up another example. Suppose this angle is 40 degree. Just for example, you need to write the sense of this direction. Give it a try. You should write it 40 degree south of west. See, you have traveled 40 degree along the south of west, or the same thing can be written in another manner. This will be 50 degree then you will write it 50 degree west of south. Clear? One more example I am considering. Let's say this angle is 60 degree. Post your opinion in comment box regarding this sense of direction. You will write this as 60 degree west of north. Why? You can check it here. You have traveled 60 degree in the west direction and you have started from the north direction. Or the same thing can be written again in another way. 30 degree. In which direction you have to travel? North of west. I hope you get my point. Okay. And this north, south, east, west can get changed. It's not fixed. Suppose in some other question you want to rotate this reference frame. It means the east will come here, the south will come here, the west will come here, and the north will come here. You have rotated this frame by 90 degree. Now this is also correct one. When you start solving any question, then you consider some reference frame, and once you consider any particular reference frame, you should stick to that one until the question is over. Both are equally correct. If you consider that one, you will get correct answer. If you consider this one, you will get correct answer. Even you can set another orientations as per your requirement. This choice entirely lies upon us. Fine. Here is the next example. You have to represent a force of 5 Newton along northeast. Give it a try yourself. I am solving it on board. Let's say we choose the sense of direction north, south, west and east. So the northeast direction will be here at an angle of 45 degree. Okay, this will be the northeast direction. And here you need a force of magnitude 5 Newton. So let's say this red vector is representing a force of 5 Newton. Now this F vector can be written as what? 5 Newton I cap plus j cap by root 2. Do you remember what was the unit vector along this direction, northeast? Check your notebook. I cap plus j cap by root 2. The unit vector here was I cap, here was j cap. Okay, so it's a simple representation. Note it down. Let me create another question for you. Give it a try yourself. 60 degree north of west. So here is the west direction, and from here you need to go 60 degree. From here 60 degree might be like this. Okay. And the velocity is 3 meter per second. If this magnitude represents the length 5, then the length 3 will be smaller than this. So let's say we represent it like this. Here is the 3 meter per second. I hope you get this. Okay, note it down. Our next topic is the null vector or zero vector. As the name indicates, its magnitude will be 0. And since the magnitude is 0, its direction will be indeterminate. Because if something is 0, how you can talk about its direction? This zero vector has no practical use in physics. We are just reading it for the mathematical consistency. For example, if you add the a vector and minus a vector, the answer will be zero vector. If you add the a vector and zero vector, the answer will be again a vector. If you subtract the zero vector from the a vector, the answer will be again a vector. If you multiply the zero vector with the a vector or any number, the answer will be again zero vector. Okay. So you can note it down. Our next topic is the multiplication of a scalar with a vector. Let's learn it through few examples. Suppose we have the f vector is equal to 3 Newton I cap. I cap means this force of 3 Newton is acting along the x-axis. Now I define another vector. I call it as f2 vector. 2 times of the f vector. How you will represent it? The magnitude will get doubled and the direction will be the same as the old f vector. So we have to double this magnitude. It means this should be the representation of the f2 vector. Getting it? Let's take another example. Suppose I define another vector as f3 vector, and that f3 vector I write as minus 1 by 3 of f vector, let's say. Now this time I am multiplying with a negative number. It means the new vector will be in the opposite direction of the old vector. So if this is representing the 3 Newton force, then I should represent the f3 force like this. Okay. The magnitude is 1 by 3 of the old vector and the direction has been reversed because of this negative sign. So if we multiply a given vector with a positive number, then the direction of the old vector and new vector will be same and magnitude will change as shown in the diagrams. If we multiply the given vector with a negative number, then direction of the new vector and the old vector will be opposite and magnitude will get changed as shown here. Fine. Taking up another example. Suppose we have a velocity vector of a car v is equal to 2 meter per second of I cap. Okay. Now I define another vector as p1 vector, and this I write as 5 kg multiplied with v vector. It will be 5 into 2 means 10 kg meter per second of I cap. See the interesting thing, if we multiply a scalar quantity like this, the magnitude is getting changed as well as the physical quantity is also getting changed. Earlier it was the velocity and now it is the linear momentum. Since I have multiplied with a positive data, so the direction of the old vector and the new vector are same. So the concept is pretty simple. If we multiply a given vector with a positive number, then the old vector and the new vector will have the same direction and the same units. And if we multiply a given vector with a negative number, then the old vector and the new vector will be in opposite direction and they will again have the same units, they will represent the same physical quantity. But if we multiply a scalar physical quantity with a vector physical quantity as shown here, then the new vector will be a different physical quantity as compared to the old physical quantity. Getting it? Note it down. Then we'll go further. Here we have a nice example. If the angle between A vector and B vector is 30 degree, so I am representing that. Let's say this is A vector and this is the B vector. According to the question, angle between them is 30 degree. Then we have to find the angle between A vector and 3B vector. The solution part is also pretty simple. This is the A vector. Okay. 3B vector means what? You are multiplying it with a positive number. So its length will become 3 times and direction will remain same because this number is positive. So I think we should draw the 3B vector like this. Getting it? Now what is the angle between A vector and 3B vector? It will be same as the previous one. So first part will have the answer as 30 degree. Clear? Now going to the second part. Now can you pause and give the answer for the second part in the comment box? Same way you can do the calculation. You have to consider the 2A vector and minus B vector. So 2A vector means its length will become twice and direction will remain same. So somewhere here I am representing the 2A vector. Length is double of the A vector and direction is same because this number is positive. Then there is minus B vector. Minus 1 if we multiply with this vector, it means the magnitude will be same but direction only will get reversed. So that minus B vector should be here. Do you agree? Now the calculation is pretty simple. This angle was 30 degree. So this will also be 30 degree. We need the angle between 2A vector and minus B vector. So you can tell the answer very easily. Your answer will be now 150 degree. Getting it? Okay. You can note down up to here, and if you have any doubt, you can post it in the chat box. And on the next screen, you'll be getting a checkpoint. You should pause there and you should try to solve those questions yourself. Now we'll read few important points regarding the vectors. First point, if a vector is displaced parallel to itself, it will not change. What does it mean? Suppose we have a vector like this and we call it A vector. And then you displace it here. And let's say we call it B vector. Then A vector and B vector, they have the same magnitude as well as the same direction. So technically we should be writing that A vector is equal to B vector. Or you can do one more thing. This vector you displace like this here down and you call this as the C vector. Then you see the C vector and A vector have the same magnitude and the same direction. So actually you can write here equal to C vector also. Suppose you displace this vector little bit up here like this and you call it D vector. Then the D vector has the same magnitude as the A vector and has the same direction as the A vector. So eventually you can write this. Getting it? So if a vector is displaced parallel to itself, then that vector will remain unchanged. It will indicate the same physical quantity, it will indicate the same direction as the previous one. Okay, note it down. Then we'll take up point number 2. Second point, see it here. Suppose we have a vector in this direction and we rotate it by some angle like this. This angle is theta. Okay, and this red vector I call as B vector. The A vector and the B vector has the same magnitude, but they have the different direction. So we should write that A vector is not equal to the B vector. Getting it? Another example. We consider the A vector like this. And now we rotate it 360 degree. Starting here, I rotate it like this, and then bring it back here. Then the new vector and the old vector, are they same? Yes. If you rotate it by 720 degree, it means one complete rotation, then next complete rotation, then the old vector and the new vector will be again same. So in this case, A vector is not equal to B vector, and in this case the A vector and B vector will be same. Getting it? Note it down. Then we'll take up point number 3. Here is third point. If the frame of reference is rotated or translated, the vector remains unchanged, though its component may get changed. We'll talk about that later on. I'm explaining the things here. Let's say this is x-axis and this is y-axis, and we have a vector like this. Okay, we call it, let's say, A vector. A vector has this much magnitude and pointing in this direction. Now I rotate the frame of reference, means this becomes x dash and this becomes y dash. We have rotated this frame of reference little bit. These x's, now they get rotated like this. After this rotation, again if you look at this vector, does it get changed? This vector is yet the previous length, yet the previous direction. So the frame of reference might get rotated, might get translated, the vector will remain unchanged. Okay, note it down. Then we'll take up point number 4. Let's see the fourth point, which is pretty important one, the angle between two vectors. In order to find the angle between two vectors, we always place them head to head or tail to tail by displacing either of the vectors parallel to themselves. And then we take the smaller angle in between them. I'm taking an example. Let's say this is a vector and somewhere here we have the B vector. And let's say if we extend the lines, this angle is given as 30 degree. Here is the tail of A vector. Here is the tail of B vector. According to the given statement, in order to find the angle between two vectors, we should put them tail to tail or head to head meeting by displacing the vectors parallel to themselves. So what I'll do, I'll displace the A vector little bit up here and I'll displace the B vector little bit here. Then their tails will meet. Do you agree? Displace the A here, displace the B here, and tails will meet. So let us do that. Taking the A vector up here, this is the A vector. Now displacing that B vector parallel to itself, displacing the B vector parallel to itself. Now both the tails are meeting here. Then you have to take the smaller angle in between them. Here is one angle 30 degree and the other possible angle is 330 degree, which should be your answer. The angle between A vector and B vector is actually 30 degree, the smaller of the two angles. Okay, there is a logic behind that. From A vector, how much you need to turn in order to go to the B vector? Then you turn 30 degree, or you can turn 330 degree. You have to choose the smaller angle out of these two possibilities. That's the logic. I'm repeating it. Suppose from B vector you want to turn toward the A vector. From B vector you want to turn toward the A vector. Then how much you need to turn? Either 30 degree like this, or you need to turn 330 degree like this. You have to choose the smaller angle out of these two possibilities. So your answer is 30 degree. Okay. Taking up another example, suppose we have the A vector here. Here is the tail of the A vector, and somewhere here we have the B vector. Here is the head of the B vector, and this angle is given as 120 degree. The question is same as the previous one. We have to find the angle between A vector and B vector. Pause the video here and give your answer in the comment box. According to the given statement, either both tails must be meeting or both heads must be meeting. That is not happening here in this diagram. So we need to displace the vectors parallel. That can be done in two ways. Pay attention. First way is this. I displace the B vector here. Do you get this thing? B vector can be displaced parallel here. Then how the diagram will look like? A vector here, and that B vector from this location has been displaced here. Then both the heads are now meeting. Here is the head of A, here is the head of B. This angle by geometry we know will be 60 degree, and this angle by geometry you know is 300 degree. Now which is the smaller angle when the two heads are meeting? 60 degree. So that should be your correct answer. It can be done in another way. You keep the A vector here only. Okay. I'm making another diagram. Keep the A vector here only. And this B vector, you displace up like this. So here will be the B vector. Now you check one thing. Here is the tail of the B vector, as well as here is the tail of the A vector. Both the tails are meeting, and then this angle is 60 degree and this bigger angle is 300 degree. We know out of them we have to choose the smaller one, and the logic is same as the previous one. In order to go from A vector to B vector, you have to turn either 60 degree or you have to turn 300 degree. You will choose smaller of them. Clear? Note it down. We'll take few more examples. Taking up the next example, suppose this is A vector and this is B vector, and this angle is given as 45 degree. Question is the same. Find the angle between A vector and B vector. Post your answer in comment box. It's a simple one. You know that here is the head of A vector and the tail of B vector, and according to the statement either both heads must meet or the tails must meet. So we'll do the parallel displacement. This can be done by displacing the B vector here. I am doing that. Here was the A vector, and this B vector has been displaced parallel like this. Okay, displacing the vector parallel will not change it. Now, how much is this angle? You know the geometry. This angle is 135 degree. Okay. So the angle between A vector and B vector when their tails are meeting is 135 degree. There is one more possible way. We can keep the B vector as it is and we can displace the A vector. What I mean to say, the B vector is kept here only. Earlier the A vector was here. and I have displaced now the A vector like this. Now see the interesting thing, here is the tail of the A vector as well as we have here the tail of the B vector. This angle was given as 45 degree to us. In the diagram we have that data. A vector from here we have shifted like this. And this total angle will be how much? 225 degree. And this angle will be 135 degree. So among these two possibilities, which is the smaller angle? You know that 135 degree, that should be your answer. Logic is same. In order to go from A vector to B vector, or in order to go from B vector to A vector, we have two possibilities. Either we turn by 135 degree or we turn by 225 degree. Getting it? A vector to B vector, you can turn 225 degree. A vector to B vector, you can turn 135 degree. Smaller possibility will be our answer. Or vice versa. B vector to A vector, you can turn 135 degree. Or in order to go from B vector to A vector, you can turn 225 degree. Smaller possibility is the answer. Clear? Note it down. I'll be taking up the next example then. Here is the next example. We have a right angled triangle and we need to obtain the angle between A vector and B vector, B vector and C vector, and C vector and A vector. You can pause here and you can give it a try. It's a pretty simple question. I'm solving the things on the board. The first part is asking the angle between A vector and B vector. So you check here is the tail of the A vector as well as the tail of the B vector. Then we have two angles possible. This one is 90 degree and this one is 270 degree. And we go for the smaller possibility. So the first answer will be the 90 degree. Next, angle between B vector and C vector. Check here. Here is the head of the B vector as well as the head of the C vector. So both heads are meeting and the possible angles you can see here. This is 45 degree and this angle is 360 degree minus 45 degree. Which one is the smaller one? This one is the smaller one. So for second part, the answer will be 45 degree. Okay. Last part, the angle between C vector and A vector. Here is the tail of the C vector and here is the head of the A vector. Can we take up this angle? No. We need to do the displacement. So either their tails must meet or their heads must meet. So what I am doing, this A vector, I'll displace parallel like this. So the tail of the A vector will meet with the tail of the C vector. I am making the diagram here. A vector has been displaced parallel to its previous position. C vector was somewhere here. And this angle, the initial angle here in the diagram was 45 degree. We know that this angle will be 135 degree and this angle will be 360 degree minus 135 degree. So going from A vector to C vector, we have two possibilities. A vector to C vector, we can traverse the angle of 135 degree, or A vector to C vector, we can traverse this bigger angle. What should be your answer? The smaller one. Means 135 degrees should be our answer. Clear? You can apply the same logic. If you go from C vector to A vector, you can traverse 135 degree or you can traverse like this. The smaller possibility is the answer. Done? Note it down. I'll be taking up the next example. Here is the last example of this video. We have to find the angle between A vector and B vector, angle between B vector and C vector, and angle between C vector and A vector. You can pause the video here and post your answers in comment box. I hope everyone will get the correct answers. I am writing the solutions here. The tail of A vector is visible here, the tail of B vector is visible here, as well as the tail of the C vector is visible here. In order to solve the first part, the angle between A vector and B vector, I can displace the A vector here. Do you understand this diagram? So the A vector will look like this. This angle is 30 degree and the B vector is already here. This is also making an angle 30 degree. Both the tails are meeting, the tail of A as well as the tail of B. So the answer should be 60 degree. Pretty simple. Next is the angle between B vector and C vector. Let's simplify that here. The B vector is at its own place like this. Angle is given as 30 degree. Okay, here was the B vector. And then I shift the C vector parallel here like this. Then both the tails will meet. So the C vector is here. Now you have the tail of the C vector here. You have the tail of the B vector here. And this angle is given as 45 degree. Your target is the angle between B vector and C vector, means this angle. Everyone can tell this answer is 15 degree. So here is the second answer, 15 degree. Clear? Last, the third part. I am displacing the A vector here. So with respect to the x-axis, the C vector is like this, making angle 45 as shown, and the A vector has been shifted parallel here. That A vector was making angle 30 degree. Now we have the tail of the A vector as well as the tail of the C vector meeting at the same point. So angle between them, our answer this time must be the 75 degree. Smaller of the angle, although there is one larger angle, but we won't consider that. Getting it? So this is all about this video from my side. Now you will be getting a checkpoint. You can pause there and you can solve it, and thereafter you'll get answers of all the checkpoints. Stay awesome. Take care.